Welcome to this tutorial. Today I'm excited to introduce a new script for the Leica Cyclone 3DR software that automates routine measurements. The script is based on an original design by my colleague Bjorn with some improvements I have added. The main goal of this script is to enable you to create custom scenarios for automatic measurement extraction. It's particularly useful in prefabrication applications where you need to extract measurements according to predefined standards. This can be applied to a variety of settings such as offshore platforms, structural steel components, shipbuilding projects, modular construction elements, and even manufacturing of large-scale equipment. With this script you can extract lengths and angles, compare them with nominal values and generate detailed reports. Let's dive in and see how it works. Before running the script, it's essential to establish some reference points. You can use spheres to mark the points that will serve as a type point. Start by using the standard Draw Sphere tool to place spheres at all locations between which you need to extract measurements. Depending on the scenario, different snapping options might be more effective. For instance, when working on an offshore platform, you might need to extract measurements between pipe joints. In that case, you can fit a cylinder into point cloud and use their intersection as a snapping point. Alternatively, in other scenarios, the new edge corner snapping tool can be useful, allowing you to create a sphere directly in the corner of a room, for example. Additionally, you can use sphere targets while scanning, which enables you to automatically fit spheres into the point cloud. These sphere targets could also be 3D printed and physically placed into cylindrical holes of steel components or positioned on their edges. This provides a practical way to integrate physical reference points directly into the fabrication process, ensuring precise alignment and measurement. Once all spheres are defined, you can run the script. In the pop-up window you will see various options: create reference points, length measurements, angle measurements, and perpendicular measurements. You have the option to select all checkboxes and run them simultaneously, or you can execute them one by one. However, it's crucial to follow the specific order. You cannot perform the angle measurements before running the length measurements, as this tool requires the lines created during the length measurement step. Create reference points in sphere centers involves generating a vertex point at each sphere center and automatically assign a name to it. This step is necessary to view all the names for the spheres, which will be required for the next step, where we will create a rule for length measurement based on these names. Length measurements. Now you can see the names of each sphere and define the order for creating lines between them. Select the length measurements option and click the Start Operations button. In the pop-up window you will see two options: simple measurements and all analysis with tolerances. So simple measurement option allows you to create lines between specified points and extract their measurements. And analysis and tolerance option create lines with the same behavior, but also compares the length of the line with the nominal value that you can define. If the line is within or outside the specified tolerance, it will be marked with a special color. After choosing one of the above options, the script will ask you to select a scenario for line creation. You have three different options: default set, sequential pairs, and custom selection. With default set, script will use predefined rule for line creation, useful when you need to extract measurements consistently in specific order. You can change this order directly in the JavaScript file. You should look for this section. The numbers in the brackets represent sphere names. Each pair of spheres will be used to generate a line. For example, 8, 10 means a line will be generated between 8 and 10 spheres. You can change this order or add more pairs for line generation. If you select sequential pairs, lines between spheres will be created in sequential order based on their names from the first to second, from second to third, from third to fourth, and so on, up to the 10th. You can change the maximum number of spheres in the script file. If you choose custom selection, the script allows you to create your custom rule. You will see available options for each sphere in the next window. For example, you can select checkboxes with all points for sphere 1 where you would like to create lines, and then do the same for sphere 2, sphere 3, etc. Once you define the order, click Continue. The script will extract the lines in the specific order and create label for each line with its length value. If you selected Analysis and Tolerance option in the first step, after setting the line order, another window will prompt you to specify the nominal value for each length and the tolerance used for marking the label and line. For example, you can define that the nominal length between spheres should be 8.5 meters, with tolerance 1 cm for good values, 2 cm for warnings, and anything above marked in red as an error. After performing the measurements, you will see that lines are created and colored based on the difference from nominal values. Labels for each line will include information about length, nominal value, difference, and status. Additionally, a relevant report page will be generated. Of course, all these measurements could be extracted manually, but this approach would be very inconvenient, especially when comparing them with nominal values. In my scenario, I need to use different nominal values for each line, which makes manual extraction tedious and repetitive. Automating this process saves time and ensures consistency, especially when extracting the same set of measurements repeatedly. Now that we have the lines created, we can process to extract angles and perpendiculars. Keep in mind that these options will not work before the lines are defined, as they rely on the presence of lines for their calculations. Run the angle measurements option and you will see options similar to those you encountered earlier for lines. So in the first step, it will ask you to select option for measurements, just simple measurements or analysis with tolerance. Next script will ask you to define the order for angle extraction. The script will display all available options for each pair of lines. Each line will have a name based on its points. If you need to adjust the predefined order, you can edit the JavaScript file. After defining the order, specify the nominal values for each angle and its tolerance. For instance, you might define the nominal angle of 90 degrees with a tolerance of ±1 degree for good values, ±2 degree for warnings, and anything outside this range marked as a red. As a result, the script will generate arcs based on the selected pairs of lines. Each arc will have a label displaying the angle value, nominal value, tolerance, difference, and status. Additionally, a relevant report page will be created similar to the length measurement scenario. Perpendicular measurements. For the perpendicular measurements, the process is very similar to the previous steps. You will see the same options. Just measurements or analysis, then define order. The main difference in this step is that the script will ask you to specify a pair consisting of a point and a line. For example, you might select a point, sphere 8, and a line L10. The script will then calculate the perpendicular distance from the selected point to the specified line. Then add nominal values and tolerances. Just like with the length and angle measurements, you can define nominal values for each perpendicular measurement and specify tolerances. Once the perpendicular measurements are extracted, the script will generate lines representing the perpendiculars colored based on their status, within tolerance, warning, or out of tolerance. Each line will have a label displaying the perpendicular distance, nominal value, tolerance, difference, and status. Additionally, a relevant chapter will be added to the report summarizing all the perpendicular measurements, their difference from nominal values, and their statuses. Once you have completed all your measurements, you can organize your work by creating preferred views for each type of measurement. After that, navigate to the Report Generation tab to start building your own report. In the Layout section, you can customize the page list settings, such as page size or orientation, for example. In the Chapters tab, you will see that separate pages have already been created for different types of measurements, including lines, angles, and perpendicular measurements. In the Data tab, you will find separate tables automatically generated for each type of measurements. These tables will serve as a foundation for your report. Just drag the relevant views into the report window, adjust the view settings such as background color, label size and position, scale, etc. Then insert the data tables. Just drag and drop the corresponding table from the data into your report. If needed, include additional dashboard views or text to enhance your report. Once everything is set up, you can finalize your report and export it as a PDF for printing or sharing. And that's it, you're now ready to create professional reports with customized views and data tables.